This is part 2 of online lecture 2. In this part, I will show you how to determine the wavelength of monochromatic light using Young double slit experiment. I will show you the determination of the wavelength of monochromatic light using a software. I will provide you a wave interference zip file for your practice. You will also perform this experiment in physics lab. This is the wave interference EN zip file. At first, unzip the wave interference zip file. So extract file here and then double click on the wave interference EN file. Then you will see a window like this. There are 4 options here: wave, interference, slits, and diffraction. So double click on the slit option. Then you will see a window like this. In this window, click on the laser pointer from the left toolbox for choosing the light wave. So click on it. Add the screen to see the interference pattern. Click on the graph and intensity options. The default option is single slit in this simulation. Change it to double slit by clicking the down arrow. Turn on the light of the light generator at the left side. Then you will see the interference pattern on the screen. Now stop this simulation using the paste color knob in the bottom. Measure the value of distance between the slit and the screen. and the distance between the two slit and separation distance between two successive bright fringe by using the yellow color tape in the top right corner of the simulation. So this is the tape. So you have to drag out from the box, and then you have to measure the source to screen distance first. Let measure it. So this is 2480.3 nanometer. So note it down. This is the value of L, and then measure the D, the separation distance between the two slit. So you have to measure from the middle of the slit 1 to the middle of the slit 2. So this is, I think this is right. So it will be 1510.4 nanometer. This is the value of D. And then you have to measure the value of beta, the distance between two successive bright fringes. Substituting the value of L, D, and beta in equation 10, you can calculate the values of the wavelength of green light. You can also directly measure the value of wavelength from the plane wave. The wavelength is the peak to nearest peak distance, or the distance between two successive bright lines. So you have to measure. So drag the tape here, and then so this is the wavelength of green light. So you can directly measure from this plane wavefront. And you can compare the measured value with your calculated value. You can determine the wavelength of any monochromatic light by choosing that particular color from the spectrum here. So if you change the color from here, from green to red, then you can determine the wavelength of red light. If you change from red to blue, Then you can determine the wavelength of blue light by measuring the value of beta. So in this way, you can determine the value of the wavelength of any monochromatic light using Young double slit experiment.